Take a look at number 18 on page 82. Got a couple of parallel lines. And we've got a transversal that would intersect here. And we've got a transversal that would intersect here. And we've got a third parallel line right down the center. We know that this is 120 degrees. We know that this is 2x plus y. We know that this is 2x minus y. And we know that this is 140 degrees. So in terms of these two parallel lines, we've got a pair of same side interiors. And we know something about the sum of same side interiors. If the lines are parallel, those two angles have to give 180 degrees. And in terms of these two parallel lines, we've got another pair of same side interiors. And we know that the sum of those two have to equal 180 degrees. Now you've got to remember something about systems of equations. You've got two variables in each of these equations, so we're going to need to solve two equations simultaneously. The most straightforward method is to add the two equations together. Now look at these two equations, and can you tell what's going to happen to those y's if we add every like term of equation number 1 to every like term of equation number 2? 4x plus no y's plus 260 equals 360. So in essence, we've got 4x plus 260 equals 360. Well, that's an equation I know that you all can solve. 4x equals 100, x equals 25. Well, if x equals 25, don't forget that we need y. 2x minus y has to equal 40, because the supplement of 140 is 40. And if we know x, two of them minus y has to equal 40. Well, 50 minus something has to equal 40. Negative y equals negative 10. Y must then equal 10 by the multiplication property of equality or the division property of equality. So our x is 25 and our y equals 10. Go ahead and do number 19 by the same method. That is using a system of equations. And check your answer in the back of the book. By now you realize that I'm going to check your work for number 19 and that you're going to need to have checked your answer. So the next thing we're going to do, well, you're going to stop and do number 19 and check your answer in the back of the book, and then you're going to come back and we're going to write a proof for number 20. So you stop the tape now and come back when you've done number 19. How did number 19 go? Yes, really, you have to go back and do number 19 before you come back and do 20. So go do that. So we're going to write a proof that goes with this situation. Got a couple of parallel lines. I'm going to go ahead and highlight them just because they're easier to look at. I see that 5 and 8 are same side interiors. 1 and 4 are same side interiors. So I've got a lot of supplementary pairs. Angle 1 and 2, angle 2 and 6, angle 6 and 5, angle 5 and 1, angles 5 and 8, 8 and 4, 4 and 3, 3 and 7, 4 and 8. All supplementary pairs. So I can find out a lot about this situation because this is such a straightforward pair of parallel lines. But we're told that K is parallel to L, so let's not forget to mark K and L, and K parallel to L, angle, and we're asked to prove that angle 2 is congruent to angle 7. Okay. So take a look at what we're going for here. Now, in writing a proof, it would be great if we could use that alternate exterior angles were congruent, but we can't really use that postulate to prove that alternate interior angles are congruent, so we're going to have to find some other method. So let's use the fact that 2 is congruent to 5 by vertical angles, and let's use the fact that 5 is congruent to 7 by corresponding angles, and then we can use the fact that 2 is congruent to 7 by substitution or the transitive property. So we know how we're going to get there, we just have to write out all the steps. So here's our given. So let's start down here with 1. K parallel to L, N diagram. Those are our givens. And we're just putting in the steps. Angle 2, that was, from up here, congruent to angle 5. And that was by vertical angles. Angle 5, congruent to angle 7. Here's the long one. If 2 parallel lines are cut by a transversal, then what kind of angles are 5 and 7? Then corresponding angles are congruent. And from here, if we know that 2 is congruent to 5, but 5 is congruent to 7, we can say that angle 2 is congruent to angle 7, and that's by the transitive property. I would also take substitution here from step 3. And have we proven what we set out to prove? Indeed we have, that 2 is congruent to 7. You do number 21. Prove that angle 1 is supplementary to angle 7. Well, I know that angle 1 is supplementary to angle 4, don't I? We've used that a couple of times in these recordings today. And I know that angle 4 is congruent to angle 7. So please think about why. So you're going to stop the tape. You're going to go ahead and do number 21. And then come back and we're going to take a look at another one. So go to 21, check your answer with the back of the book. How did 21 go? Go back and finish 21. We're going to take a look at number 22 that asks us to write a proof to theorem 3-3 that says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. So here's line K, draw the drawing first. Line N, the transversal looks to me like T, but that might be L. So you copy that however you see that on page 79. Angle 1, angle 4, angle 2. We're asked to prove that angle 1 is supplementary to angle 4. So take inventory of what you've got there. I haven't marked my lines parallel, have I? It's given that K is parallel to N. And it's given that T cuts K and N. And we're asked to prove that angle 1 is supplementary to angle 4. Well, what do we know? We know that angle 1 is supplementary to, let's call this angle 3. We certainly know that. And we know that angle 4 is congruent to angle 3. So if angle 1 is supplementary to angle 3, but angle 4 is congruent to angle 3, then angle 4 has to be supplementary to angle 1. So we can start with given K parallel to N and the diagram are given. We need the diagram in the proof because we're going to rely on the fact that this is drawn to be a parallel line. So your job is to show